right, guys, I am going to take you through the real number system in 5 quick slides. Now, before I begin, I just want to remind you the reason why we really need to understand the vocabulary about the real number system is because down the line you're going to get word problems and you'll be in situations and they'll talk about something being an integer or a whole number or a rational number, and you'll wonder, what are they asking me to give them? So it's really important that we start with making sure you know what this vocabulary is, and some of it you probably already know, so it'll make adding on the other pieces much easier. So here we go. First thing we're going to do is start with counting numbers, just like you do when you're a little kid. When you learn to count, you start with the numbers 1, 2, 3, 4, 5. You don't start with negative numbers. You don't start with 0. Most parents, when they, teach their kids to count on their fingers, starting with the number 1. So we'll talk about counting numbers as being the base for all of the real number system. The next thing that we'll add to the counting numbers is the number 0. This makes the whole group called whole numbers. So whole numbers are not just 0, but 0, 1, 2, 3, 4, 5, going all the way up infinitely. So remember that whole numbers start with 0, and 0 looks like a whole, so that's an easy way to remember that whole numbers include 0. All right, we're going to go one level up again, and we're going to add integers. When people talk about integers, they're generally talking about negative numbers, but keep in mind that integers are all whole numbers plus their opposites. So integers include -4, -3, -2, -1, and 0, 1, 2, 3, 4. So if someone is asking you for a solution that's an integer, they're asking you for 5 or -3 or 7. They're not asking you for a fraction. They're telling you the solution is not a fraction. So integers are positive and negative whole numbers. All right, that brings us to what are known as rational numbers. Rational numbers are counting numbers, whole numbers, integers, but often more specifically, fractions and decimals. Those fractions and decimals can also be negative, so we call those rational numbers. So often when teachers will talk to you about their rational number unit, they're talking about fractions, like let's learn to add fractions or multiply decimals. Those are your rational numbers, which hopefully leads you to the question, what the heck are irrational numbers? And that's the next piece of the whole puzzle. Irrational numbers are numbers that have no pattern and continue infinitely. So I'm going to say that again so that you're hearing it. They have no pattern whatsoever. So 0.2222222, that's rational. That has a pattern. Irrational numbers have no pattern and they continue infinitely. They go on and on and on. So if you were to plug in radical 2 in your calculator, you'd get a number that shows no pattern and seems to go on infinitely. Pi, which is the circumference divided by the diameter of any circle, gives you an irrational number. Radical 7, irrational. E, which is Euler's number, people often talk about being irrational as well. Again, it goes on and on with no pattern. And then finally, the big one that probably impacts you more than all of these others is whenever you divide by 0, you get an irrational number. So it is a error on your calculator, and it's an irrational number. A long, long time ago, one of my kids told me, you can put the egg on the table, but you can't put the table on the egg. And that was an easy way to remember that the 0 on the bottom will crack, or the egg will crack when the 0 is on the bottom. But if it's sitting on top of the bar, it's fine. So irrational numbers. And then finally, when you put all of this stuff together, that's the real number system. So irrational numbers are real. Rational numbers are real. Integers are real. They're all real. All right. Thanks for playing.